Alright, conditional statements. A conditional statement, a statement with a condition on it, is a statement that can be written as an if-then statement. So for example, if today is Saturday, then we don't have to go to school. Now the parts of a conditional statement are the hypothesis, which is different from the hypothesis you know of in science. So the hypothesis of a conditional statement is the part of the conditional following the word if. So in my example above, today is Saturday is the hypothesis. And we generally underline the hypothesis once. Now my conclusion is the part of the conditional following the word then. So if again from my example, we don't have to go to school is the conclusion. And we usually underline that part of the conditional twice. Okay? Now notation, for some strange reason, we use the letters P and Q when we're talking about conditional statements. And what we do is we have P is going to be the hypothesis, Q is going to be the conclusion, and we put this little arrow between them. Now when we have the P arrow Q, the way that is read is that if P then Q. So let's see if we can identify some hypotheses and conclusions. Alright, so if I want to buy a book, then I need some money. So my hypothesis again comes after the word if, would be I want to buy a book. Again, notice it does not include the word if. So my conclusion then would be the part that comes after the word then, so I need some money is going to be my conclusion. Alright, number 2, today is Thursday would be my hypothesis. Tomorrow is Friday is my conclusion. Now the sentence, call your parents if you are running late, is a little bit tricky because my if is not the first word in the sentence. But again, my hypothesis is still the part of the sentence coming after the word if, so you are running late is my hypothesis, and call your parents is my conclusion, even though it's at the beginning. So if we're given a statement, to write that statement as a conditional, we want to identify what is the hypothesis and what is the conclusion. And the best way to figure that is usually figure out, okay, which part of the statement depends on the other part. So if I've got the statement, two angles that are complementary are acute, well, the kind of the main part of that sentence is two angles that are complementary. So that's going to be my hypothesis. And then acute, are acute is going to be my conclusion. So the way that I do that then is I'm going to put that together and say, if two angles are complementary, then they are acute. So notice I had to add some words in order to kind of make it work out as a nice grammatical sentence. But it's still, it kind of means the same thing, we just added the conditional part to it. So let's look at even numbers are divisible by 2. So again, the main part of this is even numbers, and then are divisible by 2 is going to be my conclusion. So again, turning this into a conditional, if a number is even, then it is divisible by 2. Now there's probably several other ways you could word this, but you want to kind of get the general idea here of this, your hypothesis and your conclusion, putting them together. Now you can't just say if even numbers then are divisible by 2. Okay? You need to make a sentence that actually kind of reads like a nice grammatical sentence. So sometimes you have to add words, sometimes you have to move words around, but try to make it as readable a sentence as possible. Okay, the next thing we'll talk about here is what's called truth value. Now truth value is basically how is the conditional true or not. So it's T if it's true and F if it's false. Well, how do we know whether it's true or not? Well, this is kind of sound a little bit weird, but the statement is false only when the hypothesis is true and the conclusion is false. And this is because when we first started talking about counterexamples, we said that, well, okay, you want to find a case where the first part's true and the second part's false. Well, that's basically what we're talking about here. So if my hypothesis is true, my conclusion is false, then my statement is false. In every other situation, the conditional is going to be true. It may not make sense, but it's true. So again, here's kind of a table that lists how this works out. So if my hypothesis is true, conclusion is true, my statement is true. Hypothesis is true, conclusion is false, the statement is false. If my hypothesis is false, it doesn't matter whether the conclusion is true or not, the statement is going to be true from a truth value standpoint. Okay, so we're going to determine whether our conditionals are true or false. So if your zip code is 76012, then you live in Texas. Well, in the U.S., in the zip code system we have, 76012 is only applied to Texas. In fact, it's for Arlington. So if you're in 76012, if you're in that set, you're in the greater set that includes Texas, so that would be a true statement. Okay? If a month has 28 days, then it is February. Let's real quick, let's just review what is our hypothesis and conclusion here. Our hypothesis is a month has 28 days, and our conclusion is that it is February. Well, if I'm looking at this, I can think of a month that has 28 days, but is not February. Okay, so that would be a case of a counterexample. And so, for example, September has 28 days, so the first part of the conditional is true. It is February. Well, September is not February, so that's false. So the conditional is false. Okay, number 3. If 14 is evenly divisible by 3, then tomorrow is Tuesday. This is going to be one of those, again, this is why logic is a little bit weird sometimes. First off, let's look at my hypothesis here. My hypothesis is 14 is evenly divisible by 3. Since 14 is not evenly divisible by 3, it's like, what, 4 2/3, then my hypothesis is false. So it doesn't matter whether tomorrow is Tuesday or not, this statement is considered true. Weird, but true. Okay, and then next definition we're looking at is negation. Now negation, if you might think about the word negative, because they're kind of related, it basically means the opposite. It means not. So we often just will call this as not, the negation of P, kind of our shorthand for that is not P. And the notation is we put a little squiggle in front of whatever the letter is. So not P would be written as squiggle P. So the negation of the statement, blue is my favorite color, is blue is not my favorite color. Okay. And so now that we have these, we know our conditionals, we know hypothesis, we know conclusion, we've talked about truth values, and now that we've talked about negation, we can introduce the other types of conditional statements we have. So first we have our basic conditional statement, which is if P then Q. Now if we take P and Q and we switch them, we have the converse. So the converse of if P then Q is if Q then P. Now if we take our P and our Q and we negate both of them, we have the inverse. So the inverse of if P then Q is if not Q, then not, if not P, then not Q. And then finally, we have one of my favorite words to say, which is contrapositive. The contrapositive, we're going to flip the P and the Q, and we're going to negate them. So the contrapositive of if P then Q is if not Q, then not P. So how does this play out? Well, let's take a look at an example. So we've got the statement, a cat is an animal with 4 paws. So we're going to write the conditional, the converse, the inverse, and the contrapositive. Well, first off, just because I can, there's my cat. His name is Andy. He's sitting on my leg right now while I'm going through this. Bye, Andy. Anyway, so first off we want to identify our hypothesis and conclusion. So a cat is an animal is going to be our hypothesis. 4 paws is going to be our conclusion. So if we look at our statements here, if P then Q becomes if an animal is a cat, then it has 4 paws. And we're looking at kind of the definition of cat. Not that, there are some specific cats who may have, 3 legs because of an accident or whatever. But we're talking about, kind of just the generic definitional, biology form of a cat. So if the animal is a cat, then it has 4 paws is a true statement. So for the converse, we're going to flip them. So if an animal has 4 paws, then it is a cat. Well, for this to be, basically, I can come up with a counterexample to this, because a dog has 4 paws. So the first part is my hypothesis is true, but it's not a cat. So my conclusion is false. So therefore, my statement is false. Then the inverse, we're going to take our P and our Q and we're going to negate them. So if an animal is not a cat, then it does not have 4 paws. Again, a dog is a perfect counterexample for this. It is not a cat, but it does have 4 paws. So that would also be false. And then the contrapositive, we're going to flip and negate. So if an animal does not have 4 paws, then it is not a cat. And again, we're talking, biological definition of a cat. Then that would be a true statement. Okay, on a more math-related note, when n squared equals 144, n is equal to 12. So again, we're going to identify our hypothesis and conclusion. So our hypothesis is n squared equals 144, and our conclusion is going to be n equals 12. So we're going to write all of our conditionals here. So my conditional is if P then Q, which means if n squared equals 144, then n equals 12. Well, we know that if n is negative 12, n squared is going to be 144, so that's going to be a false statement. The converse, we're going to flip it, is if n equals 12, then n squared equals 144. Well, that one's true. Because, again, we know n squared is going to be 12 times 12, so it works. The inverse is if n squared does not equal 144, then n does not equal 12. That's also going to be true. Now, sometimes the negations are a little bit harder to kind of wrap your mind around. So think about it, if n squared is not 144, that means it's some other number. And the square root of that some other number could not be 12. So that's kind of what we're thinking here. Then finally, the contrapositive, we're going to flip and negate, which means that if n does not equal 12, then n squared does not equal 144. Well, we can still have an n squared equals 144 if my n is equal to negative 12. So, again, that's going to be a false statement. Now, I'm not sure if you may have picked up on this pattern or not, but the way this usually works is that your conditional and your contrapositive will have the same truth value, and your converse and your inverse will have the same truth value. They usually are kind of paired together. Now, it's possible that you may have something that's false, that every statement is false. Or you may have one where everything is true. And we'll talk about some of those as we go along. But if you have some that are mixed, that's usually the way it breaks down, is the pairs are your conditional, your contrapositive, your converse, and your inverse. So be sure that you go back and write your summaries on Objective 6 and make whatever additional notes you want to make after the work we did in class last time. And I will see you next class.